I hope you're here to learn about window functions, not anything about the Windows operating system. We're talking about the functions in SQL that use the over clause. I had a comment on my last time I did this session. He's like, I don't understand what she did. I thought this was about the Windows operating system. And I'm like, read your abstract. So I'm Christina Leo. I'm based in the Netherlands. I grew up in Nashville. I'm an independent consultant, and I just completed my MCSE for data platform. I've used my Twitter page as my About Me slide simply because I can't stress enough how valuable Twitter is for the SQL community. Not only can you keep up with what's going on here at SQLBITS by following the SQLBITS hashtag, but you can interact with all sorts of fellow SQL geeks, and if you need help on something, you can use the SQL help hashtag, and lots of smart people can come to the rescue and answer those questions for you. If you're not on Twitter already, I'd encourage you to start using it. And Brent Ozar has a really good book on how to navigate the Twitter waters if you need some help getting started. So, to the heart of things. We're going to work on window functions today. We're going to talk about what they are, how they work, what functions within T-SQL allow windowing, and then what can we do with them? Why are they useful? So, to do this right, we need to start out a little bit slowly, but hang in there with me because we're going to build as we go. A window function is basically a calculation that's applied to a set of rows defined by the over clause. They're mainly used for analytical purposes, and if you want to calculate running totals or moving averages, they can be very useful when you're working with interval-based data. We're going to take a look at some of the cool things that we can do with them, but first, to do this right, we need to spend a little time talking about the inner workings. The over clause is not really as straightforward as it seems. After all, there are three parts to it, and those parts allow us to customize the way our function's calculated. To make things worse, the customizations have different effects depending on the type of function that you're using. So things can get confusing if we don't lay it out well from the start. So let's do a review of the concepts. Most of you should be familiar with using grouped aggregates already, right? You've done counts and sums and min and max with our group by clause. A grouped function returns a single expression per grouping column. It's a scalar value. Now, I know everybody in this group's been out to dinner with a group of people before, right? What's the first thing that you do when you get to the restaurant? Oh, come on. Sorry, order drinks. Now, okay, so you've gone straight to the bar, but somebody in the group has to go up to the hostess and tell her how many are in the party, right? It's a scalar operation. Again, only one person is going to go up to the hostess stand and say, hey, there's 7 folks waiting for a table. We'll be at the bar. So only one of your group reports that count, and that's exactly how grouped aggregations work. The calculation's made for all members of the group, but only a single row is reported. Now, at the end of the night, the hostess log might look like this. She's got information for each group as a whole, but that's as granular as it gets. What if we're interested in more than just the group information? If we want to have the details about the members of the parties, then we're going to have to gather our information in a slightly different way. Instead of one group representative going to the hostess desk, each member of the group will need to check in when they arrive. A little bit awkward, but work with me because it's going to help explain how this works. By the time we've all checked in, the hostess log might look like this. We've got the individual names of everyone in the party, but the aggregated value of the total party count is reported for each line. So the key difference here between windowed aggregates and grouped aggregates is that you are able to maintain the data granularity when you use windowed aggregates as opposed to group. That make sense? Okay, so remember me saying that this window function is just a calculation that's applied to the set of rows defined by the over clause. Well, this is the over clause in its simplest form. I've asked it to do a count aggregation, count star, over the entire result set, No partitioning, no framing, no bells and whistles. It's just, that's the simplest overclause that you can write. And in this case, because we've asked for it not to partition anything, the entire result set, the entire window, is made up of these 4 rows. So logically, I'm going to start at my first row and count how many belong in my window and report that value as my aggregation. So if I'm at Layla, everybody in my group, there's 4, so I'm going to report that value. Make sense? Okay. As I mentioned earlier, the overclause has 3 parts to it, and these are partitioning, ordering, and framing. Now, all functions support partitioning. All window functions support partitioning. Explaining that will be straightforward. All functions also support ordering, but there's a catch, because ordering works one way for functions that support framing and another way for functions that don't. So, syntactically, ordering comes before framing, but I think it's easier to start with partitioning, go to framing, and then discuss ordering. So that's how we're going to tackle this. So we're back to our hostess log, and except this time I've got all the diners for the evening in my select output. Plus I've added their arrival time. So we can see over the course of the night, maybe it's a really tiny restaurant. We only had 17 people come to eat. If I did my count star over this set, what value would I report for each row? Exactly, because we didn't use a partition specification. We've said use the entire result set as my window. So let's fix that and add a partition by party name. I'm telling SQL to calculate on the subset of party name instead of the entire output. So each row in the overbee party is going to report a count of 5. And Pellegrin's going to report a count of 3. So this is how I'm able to subset my information and get separate values per grouped set within my output. Now, if I want to add additional names to my partitioning, say I add party name here, that shrinks my output. I had 3 only partitioned by party name, but then if I add diner last name, Kyoko gets kicked out because she doesn't match the partitioning definition. Make sense? So I've just shrunk the size of my partition. Now I can continue to add columns to this partitioning definition to get as granular as I need to get. If I put 3 columns in there that provide a unique key, then I'm only going to get 1 row at a time. So you have to keep that in mind and have to decide, okay, what do I want to calculate across? What are my main groupings when you're designing your partition choices? So that covers partitioning. Any questions? Because I'm going fast, so stop me if I lose you. So framing I want to do next. Framing is the customization you can use to control how your function's calculated in relation to the partition itself. So I've defined my partition and I've got my subset. Now framing is going to work within that partition. It can be row-based or value-based, and this is where it gets tricky. So let's bring the dinner guests back and see if we can give you guys a concrete analogy that will make it make sense. We're going to look at the Tepper party. And there's four folks that were supposed to meet for dinner, and we can see they've all arrived at different times. And Warner gets to the hostess stand and he tells her, hey, we've got 4 people in my party. And she says, okay, cool, but I'm not going to seat you guys until everybody's here. So how many are you? So he can only tell her 1. I've got 4 total, but there's only 1 of us here right now. So if we think about the frame boundary being Warner, plus everyone else in the group that precedes Warner, all of a sudden his position in the window becomes important to the calculation. So his count is 1, plus everybody in the group that came before him. Makes sense there. All right, when Hank and Katina arrive, they walk through the door at the same time, they get to the hostess stand at the same time, but for some reason the hostess writes Hank's name down first. No particular reason, just maybe she couldn't spell Katina, so she decided to wait and ask her. So he gets on the list next, and Katina's behind her. What do you think Hank tells the hostess when she says, how many people are here? How many people are in your party? 4, but how many of you are here? I heard a 3. What else did I? I heard a 2. Both answers are right. And here's why. This is where the framing gets confusing. 2 and 3 are correct depending on how you define your frame boundary. So if it's row-based, we define our frame as the current row. And in this case, I've said plus any preceding rows, all preceding rows, not 1 or 10. My current row plus everybody behind me. And then our count's just 2 because there's only one person behind him. Now, the ordering's important here, but we'll go into that in the next section. If we used a range-based definition instead of a row-based one, all of a sudden we start to use the value instead of the row position to determine who is in my group. And range wants to include not only itself, but any member rows with the same ordering value. And if I've ordered by arrival time, then I've got my current row plus any preceding rows and any rows that have the same arrival time as me. So in this case, 3 is the correct answer. The subtle difference in the way range and row work is what can mess you up if you're not aware that this happens. If you've got distinct values, you're going to get the same result whether you use range or row. But if you have duplicate values, then that's when it might throw your calculations off. SQL Server uses range as the default framing definition. So if you're not aware of when that frame definition gets applied, it can make it tricky to debug your results. So hopefully we'll solve that problem for you by the end of the session today. We'll also play with some of the, there are some, sorry. This is what happens when I get ahead of myself and I have to stop and back up. There are performance considerations between range and row that we'll look at in the demos also. And frame boundaries, I hinted at it when I said all of the preceding rows instead of only 1 or 10. There are more ways to customize those frames, and it's easier to look at that in the code. So, any questions on framing? The big takeaway there is range frames are value-based and row frames are position-based. So the last thing we need to talk about is ordering. And as of SQL 2012, there are 4 types of functions that support windowing. The aggregate functions, let me make sure I don't misspeak. The aggregate functions and the ranking functions were available in 2005, but they didn't support framing. So when framing got introduced in 2012, that's when our offset functions came into play. And I've got a list of who was available in 2005 and who was available in 2012. I can't ever keep up with it. They didn't make any changes in 2014 to the window function, so everything that was available in 2012 is still functional in 2014. So all of these 4 types will support ordering. But again, it means something different from one group to another, and the key is knowing which. Ranking and distribution functions have to have ordering. I mean, think about it. If you want to find out who's the tallest in the group, how can you do that without instantiating an order to determine who wins, right? So if you try to use a ranking or a distribution function without an order by clause, it'll bark at you, say, nope, I can't do it. I need you to provide that. So you can use it with or without partition by. Aggregate and offset functions are the ones that support framing. So if you write queries for these without specifying order by, then framing's not used at all. But as soon as you put an order by clause in your statement, if you don't specify your range explicitly, your frame explicitly, SQL Server is going to use range between unbounded preceding and current row. So me and everybody preceding me that has the same value, not my row position. So takeaway here is to explicitly define your frames, and that way you don't have any surprises when your data comes back. So again, we'll look at how we work with this in the demos. Any questions on the conceptual bits before we go to the code? Okay. So now I have to do magic here. Let's see. I'm going to go to my PC screen, and then I can minimize that. Grr. Sorry guys, this never works smoothly for me. I don't know why. All right. There we go. Demos, Control P, duplicate. Because when you use presenter mode in PowerPoint, it wants to extend. But when you want to do your demos, you need to duplicate. So you have to go back and forth between these. So I've got 6 sets of examples here. How is the size in the back? Can you guys see? Bigger? Okay. Let's do this quickly. What time is it? 2:55. Options. Did you guys know this setting exists? If I go to text editor, I think. All languages? No. Fonts and colors. That's what I want. And I'm 14, so if I go to 16, there we go. Is that better? Yeah. If I get any bigger, I won't have enough real estate. Okay, so our first example is going to use the count that we were working with earlier. Very simple query, no partitioning, no ordering, no framing. I'm pulling from my hostess log single day table, and the same data comes back that we looked at in our example previously with our 17 rows. Nothing special there. I'm going to open up number 2 and put it, why am I using my trackpad? I have a mouse. We're going to put this in a new group. Here we go. And we've got our results there that we're used to looking at. Now, I've got partition by party name, which we looked at earlier. And because we've got 1, 2, 3, 4 different parties, I've got my total count for the group for each one. That makes sense. Let's take a few rows out. Let's look at overB only so that there's less data crowding the screen. I'm going to put this guy here and open up our third. We haven't done anything different. What happens if we add an order by statement? Let's pull this over so we can see our counts. We've still partitioned by party name, but this time we're going to order by arrival time. Now remember how I said that SQL Server, as soon as I put an order by statement in for an aggregate function, it's going to put framing in for us. Now, for partition only and partition plus order by, it looks like I'm getting the same results, but that's because I have distinct values. What happens if I look at the price party? I've got 3 in my group, and I'm still same partition by party name, ordering by arrival time. And now my counts change. Remember how we said there's 1 in my group, and now there's 3 of us in our group? Because SQL Server did the range specification for us because we didn't tell it what we wanted it to do. Make sense? Giltner, again, this gets 1, 2, 3, 4, but that's because they've all got distinct arrival times. So instead, in this case, I wouldn't notice the difference between using range and row because my values are distinct. So I want to move to number 4. How do we fix our counts? If we want the number of people as they arrive to accumulate one by one instead of accumulate by values, we can force a unique ordering key. And in this case, if I put diner first name for the overbees, let's go back to the overbees on this side. So I can see they've all got the same arrival time, but they've got all different first names. So if I order by first name, then all of a sudden, because I'm still using the range frame definition, but because I've told it to order by the value of first name and count how many people have that same value, I only get one at a time. Does that make sense? Okay. So the other way to solve the problem is to explicitly declare a rows frame. And in this case, I've used the short syntax. I said, don't use range, use rows, and I want you to go between the current row and everybody before me. So I can type that just as rows unbounded preceding. And then, all of a sudden, I get the same 1, 2, 3, 4, 5 that I got when I forced distinct ordering. So, especially after we look at some of the performance considerations, use rows and explicitly declare it as often as you can. Every once in a while, there may be a case where you need to use range because your calculation requires that it's value-based. But if you don't need that value-based calculation, explicitly declare rows. All right, so that's demo 1. Any questions about how range and row? The whole point of that was for you guys to see how range and row can shift your calculation. Okay, so let's go to number 2. Would you tell me if you had questions? Yes, and I've got a link that you can go to that I'll post at the end. They're all already loaded up, as well as a backup of the database. It's small. So we talked about default boundaries for range and row. Now we want to look at some of the things that we can do with our custom framing. Here's my hostess log, not my small one, but a slightly bigger set of data with some sales totals for each diner, so we know how much they spent on food. And Sophia, she must have got stuck with the liquor bill. Hers is higher than everybody else's. So that's our raw data. If we select sum over the sales total, I want to partition by arrival date, so I'll get the total for each night. And that's all I'm doing there. Nothing fancy. But I can see from 921, I've got the same value, and then when I switch to 922, I get a different sum. So instead of having to do individual subqueries to get the total for each date, I've got it all in one place so I can work with it. In this case, if I want to get a running total, I want to see party 1 and then the sum of the next one and add the sum to it. I don't want the sum of each group. Again, I'd have to make it unique so it adds 1 by 1, and I can do that by using the party name and the arrival time because I want it to add up as they've come in. But then if I add that third value, that log ID, then that will make each row unique. So if I had, let's show you the results first. There are my values, and I can see from my first customer and my second customer and my third customer, they all came in at the same time. But because they got entered in with unique IDs for each one, then that establishes my ordering for adding up the values. Make sense? Yes, I see a question. Did I need the second order by at the bottom of the, oh, no, this is purely presentation layer. I needed that statement there so when we look at the results, you can see how it adds progressively. The order by clause is the absolute last thing to get processed in the query engine, and don't use it unless you absolutely have to, because it's additional overhead to do that sorting. So if your front end, your user interface can do that sorting for you, let it do the sorting. In this case, I just needed to show you how we're progressively adding. Good question. So in this example, I've used my shortcut syntax, and instead of having to put in the unique identifier of log ID by telling it to do rows unbounded preceding, I'm going to run all of these together. I'm going to put my statistics on because that's important. The result sets are the same. I get the same output, so logically it's correct. But let's look at the messages here. Look at this read count. Control F1. Oh, come on. Where's my zoom it? Can you see that? Reads are 300 for the first one, and logical reads are 0 for the second one. Anybody got an idea why the reads are so much higher for the range-based one versus the row-based one? Yep, it's got to go through the values to see are there any other values that belong to that group that I need to count. Very good. So again, that's why I suggest unless you need that value-based calculation, your default should be an explicit rows declaration. And that's why, because it's extra overhead that there's no reason to incur. So that was a very simple example. Let's play around with the different syntax. We've been using the shortcut syntax, rows unbounded preceding, but if I wanted to fully declare it, I would say rows between unbounded preceding and current row, me and everybody before me. So that same, we've gotten used to this same output, 50, 60, 120. What happens if I want to do between one preceding and the current row? Let me see, do I have anybody else down here? No, I can use F5, yay. Now I'm adding, there's nobody behind me, so my value here is just 50, and I'm going to take 10 and add that to the one behind me, and I get 60. 60 plus 10 is 70, 20 plus 60 is 80. See how I can start to control what gets calculated? If I change this to one preceding and one following, how many values will be tallied? Caps lock is not my friend today. How many? Three. The current row, one behind me and one ahead of me. So at 5, there we go. So I should have, there's not one behind me, so I've got 50 plus 10. And now this one I should have 10 plus 70 plus 20 is 90. So again, depending on, there's tons of power here for answering all sorts of different kinds of queries. You just have to figure out the math of how you want it to calculate. So that's the power of framing. Let me make sure there is something else I want to show you in here. All right, we did our one preceding in the current row. What do you think I'll get if I say between unbounded preceding and unbounded following? Everything, yes, the entire window. And that's that. So in the next example, let me show you some ways that we can take advantage of that. Yeah. Go back to the code. No questions? Okay. Right. Turn on the query plan. I have to make notes to myself. This is important. That's off. Now we're on. Okay. Combined aggregates. The frames are the same in my definition for daily total and my definition for monthly total, but my partitions are different. Now, I'm going to do two completely different calculations within the same query. So I've asked it to partition by arrival date and then give me the sum of everything for that arrival date, everything in that window for the daily total. And then use no partition. Yes?
Sorry. If you just left the partition by, remove the or by, take out the rows, would it then give you the same result?
Yes, if I took out the order by.
Or are you doing that because you're trying to get away from using the nested? You use the nested?
No, I've declared the rows just because I want to show all of the syntax. Yeah, if I were, yeah. Yeah, I would leave out the order by. This is the trick with aggregations and not ranking, aggregations and sorry? Yes, the lag and lead offset functions. Thank you. Wow. If you don't specify an order by clause, then no framing is applied at all. It's only when you specify order by without specifying the frame that it messes things up. Good question. So, I've partitioned by arrival date in my first calculation. I've not partitioned at all in my second calculation, and my data just happens to be all for 1 month. I don't have multiple months in here, so I can call that monthly total. So when I run this, and I get my daily total alongside my monthly total, which if I wanted to further do calculations on that, I could put those things into a subquery, or not a subquery, a derived table or a CTE. And I don't have to put that into a temp table. I can do it all within the same query. Before, without window functions, I had to use two scalar subqueries in my select statement to arrive at the same value. So I'm going to run these two together. You see how I've had to do a select statement here and a select statement here to get those two separate values. When I run these guys, my results look the same. Logically, they're correct. But when I look at my execution plan, I've done a single clustered index scan. I've hit the table once, and then I'm able to do my calculations, my two separate calculations on that one set of data that I've returned. But if I look at the second one, results, oh, I have to scroll down here. Here we go. I've got 3 clustered index scans. The reason for that, let me go back to my editor. Not only am I doing the initial select from hostess log, but I'm also doing 2 additional discrete selects with these scalar subqueries. So I've had to hit that table 3 times to get the same values that I did with the window functions. Now on this table with just a few hundred rows, it's not that big a deal, but if you're working with a million rows, a billion rows, that's a significant difference. So that's the cool thing about Windows functions. What happens, and here's another thing with the logical query processing. These values, SQL Server processes the from clause first, and then the where clause. So I've got my from, I'm doing any filters in my joins. I process my where clause next, and I filter out any additional things there. Then I do my group by or any having filters, and then my select gets processed. So it's second to last. The last thing that gets processed before order by, which is just for presentation purely. So anything that happens in this select section is not accessible until after the select has been processed. Here's what I'm trying to get at. If I take this, let's put it in another query. If I got everything, I do. New query. If I put this in, say I tried to order by, or no, let's put it in the where. Where monthly total is greater than 100. If I try to run this, it's going to bark at me and tell me monthly total doesn't exist. That's because the where happens before the select, so it's not been instantiated yet. It doesn't exist. So if I want to use these values that I'm creating, I need to either put them in a derived table like this, select, and I'm going to do select star, but in this case it's okay because I've explicitly declared what I'm pulling in my main query as x where x dot monthly total. See, now it comes up for me because it's in scope now, greater than 100. And I'm going to take that out. And let's see if I can hit the right button and make this run. Now it comes back for me, and obviously There's only one. That was a silly query because there's only one monthly total. Let's change it to 2,000, and I should get nothing back. Yay. The whole point there is that these values that we are creating with the window function in the select statement are not accessible until we've put it into an outside loop. So I can do that with a CTE or a derived table, and even a temp table if the situation warrants. That's all we needed to talk about in there. Any questions? Yes?
Can you use having?
Not in this part, but I could put a group by and a having. Having only works if you use group by. I could put that in the outer query if I needed to, if I needed a group for some reason.
It's not a question, but just a comment on that example. Some of the database platforms solve that problem with another keyword called the qualify clause, which is processed after the select, that allows you to do exactly that type of thing.
That's nice. I wonder if we'll get that in SQL. SQL Server. Cool. So that's all I had there. My next demo, we're going to look at some of the things that we can do. So now, I hope that I've covered all the concepts at this point. So you have should have a good working knowledge of how the framing works, how ordering affects things. What we understand the concepts now. Now, what do we get to do with them? We're going to use the ranking function row number. And remember when I said that ranking functions have to have an order by clause? Well, in this case, I don't really care how my data comes back. I don't care what order you assign the row number, so I'm just going to put an arbitrary select null in there, and it will still run for me, but it there's no specific order. So if I run this query, I get a transaction ID, a transaction date. We can see my transaction IDs are not contiguous. I want to rekey this data, so I can use my row number to give me unique values. And again, I've got some null IDs here, and I've not assigned any order. What if I want it to go by transaction date? What if I want to get that data in a more logical order? So I can use, I've got two queries that look the same. That doesn't, here we go. In this case, I'm going to order by my transaction date. And you can see how these null values get shifted. And again, I mean, I've got duplicates here, but I can insert this into a new table, and all of a sudden I've got IDs for everybody instead of a bunch of nulls there, and they're in order. So that's a way, very, very simplistic example, obviously, but that's a way you can use row numbering to deal with ETL transformations. If I want to deduplicate the data, oh, what have I got here? Yep. Here's a way that I can deal with my new IDs. If I want to kick out any duplicates in this case, I can use dense rank instead of row number. Row number is sequential. It adds one every time. Dense rank is going to number by the group. And in this case, I've said order by the transaction date, so everybody with the same transaction date is going to get the same rank. So now, in this case, and again, I have to put this into a derived table because I can't access the new columns that I've made within here. I have to do it from an outside query. So if I tell it to select the distinct group key, now I've got just distinct dates. I've gotten rid of my duplicates. So playing with row number and dense rank, there's some interesting things that you can do with the values. And Itzhak Ben-Ghan's book on window functions has all kinds of really cool examples of things that you can do with from a math perspective. How do we make those numbers let us do cool things with the math to eliminate gaps and islands and things like that? We'll look at some more examples, but this is a really basic example of how to rekey. If you want to deduplicate data, I don't want to rekey anything. The nulls are fine. I just want to get rid of the duplicates in this case. So I'm going to order by select null because it doesn't matter to me. I'm going to select my row number. This looks very similar to what we were using earlier. If I get to here, in this case, I'm going to partition by transaction date now. So by telling it to partition by transaction date, what's going to happen with my row numbering? When will it restart? With each new date, yes. So now all of these guys have 1 because they're on separate dates, but then I've got 9/17, I've got 7 that are for that date. That's useful to me for deduplicating because if I select where row number equals 1, in this case I used a CTE instead of a derived table just to illustrate that it works this way too. Now I get my distinct values that I want, and I'm going to put this in a transaction and roll it back at the end so I don't mess up my, my database for myself. But in this case, I'm going to use my CTE, and I'm going to delete from that representation of the data. I want where row number is greater than 1 because the 1s are my distinct values. So if I do that, it gets rid of all my duplicates for me. And that was dead easy. So that's a common use for row number and window functions. Any questions about the simple examples? Okay. So now let's look at offset functions. Lag and lead. Lag's frame definition by default is rows between one preceding and one preceding. Grab the one before me. And then lead is one following and one following. Grab the one ahead of me. Does that make sense? So for transaction history, if I want the current transaction, I'm just going to grab the transaction date. And if I want to see the date of the next transaction, I can say lead transaction date over the entire partition. So I haven't specified a partition frame. And I've just told it to order by transaction date because I want it to grab the next value. And that looks something like this. And before SQL 2000, well, no, this is 2012. This feature is not available in 2005 because that doesn't support framing. I would have to use a recursive CTE to get the next value in my output. So I've just reduced a whole bunch of lines of code and have not had to do what works out to be a cursor eventually with a recursive CTE. Here's an example of lag where I've used it as part of the, I've got my previous transaction, so I got the date of the one before me, but if I want to calculate how many days apart the two transactions are, I can put this lag as part of my date diff function. And that will give me, and the reason the days apart are null and the previous transaction's null is because it's the first one in the list. There's nobody before it. So these are some ways you can start to take the base functions and build on them to create the result set that you need. Any questions there? Okay, let's look at a date ranging example. In this case, I want to get the current transaction value as my start date, and I want to take, we're assuming that as soon as one transaction ends, the next one starts, and that they're at the day level. I'm not at the minute or second granularity. So if I want to get my end date, I want to get the next transaction date, the one ahead of me, and then here in my outer query, I'm just going to subtract 1 day from that ranged values, next transaction value. Make sense? So now I've got a sequence, 721 to 801, 802 to 807. I can use that for creating start dates and end dates if they don't exist already. I don't know how much work you guys do with temporal data, but being able to calculate those start and end dates is very useful in such a neat and elegant way to do it. So that's date ranging. let's use similar concepts in a slightly more complicated example. We're going to look for the gaps in activity. We're going to assume that our data is in the day, at the day granularity level. So if I look at this, this transaction data, I have a transaction on the 21st and then a transaction on the 2nd, but nothing happened on the days in between. So how do I find out how many, or how do I find out the ranges of inactivity, the blocks of inactive days? Does that make sense what we're after? Okay, so if I go to, let's do number 2, and I want to put this side by side. I'm going to get my current transaction and my next transaction using my lead function, and that it helps if I don't select a single word. There we go. So I've got my current and my next, just like we did previously. I'm going to open one more here. I'm going to slide this guy over here so we've got our raw data to look at. I've put this code in a CTE, so I've just copied over. And then I'm asking for the range start, get add a day to the current transaction, and to the range end, subtract a day from the next transaction. Do you see why I'm doing that? Because I've decided that the transactions are a discrete day, and if there's a gap in between, then I want the start of the first day of no activity and the end of the last day with no activity. So if I add a day and subtract a day, that I'll get that value. And then for days apart, I want to just get the date difference between the two dates. So if I run this, I can see that I've started on the 22nd. I've got a transaction here. My next one didn't start till the 2nd. So that's the range of the gap. Make sense? And in the cases where there is no gap, I had something happened on the 16th and something happened on the 17th. My days apart are only going to be 1. So if I can now use my where clause to filter out the dates that are equal to 1, I only want the ones that have more than 1 or greater than 1 because those are the ones that are actually a gap. All of a sudden I've got just a list of the periods of non-activity. So again, this is a really simplistic example, but it's to illustrate how if you can figure out how to think about the math between the intervals, you can do some pretty powerful things. You can reverse this and say, I've looked for gaps here, but what if I want the islands? What if I want the periods of activity? I could play around with my math and my filtering to return that information. Yes?
Can you cap the lag or lead so that you only want to look back, say, 15 days?
You can't with lag and lead. That's hard-coded, one before and one after. But you can use your rows, one following and one preceding, or two following and one preceding. That's how you would customize your the thing here, dates, when you try to say, like, give me 1 quarter or 2 quarters or 3 quarters, because we don't have there's no way to tell it to count intervals of dates. You can only say where, you can only tell it how many preceding. So if I tell it 3 preceding, that'll work for quarters. No, 4 preceding would work for quarters if I have no gaps in my dates. But as soon as I have gaps, then it doesn't work because you'll have to fill in with a tally table, you'd have to fill in the missing ones to get it to work properly. Does that make sense?
Yes.
Cool. So that's gaps. And the one last thing I want to show you has to do with optimization. So we haven't really talked much about that except for where we looked at the reads with range and row. There is a specific way that you can index to make these queries work a little bit better. Let's look at the query plan with no index at all. I'm asking for the store ID, the transaction date, the actual cost, I want my, I want a row number, but I've partitioned by store ID and transaction date, and I'm using the transaction ID as my ordering key. So now I should get, when I get to 2, I should have a different store. Oh, I've got a lot of data in here. Oh, store 34. Oh, come on. Slow down. There we go. So yeah. Not only each different store, but each different day. So I've got I'm counting up the transactions by day, by store and by date. So I start over again when I get to a new date, and then obviously when I get to a new store. So if I look at my execution plan here, I've just done an index scan, and I must have my index on here because I should see a sort in this. So let's look at our window functions and transaction history. Transaction history. Indexes. Yes, I do have an index here. So let's drop this guy. All right, now rerun. Yes, there's my sort. The reason it needs that is because it has to first know how to group the data for the partitions, but then also to order by transaction ID. It's got to put, because I've got no index to do it for me, it's got to insert this sort operator here to do that work. So the whole point of this is if you know this is a query that's going to be used often, and you can go ahead and add the indexes to the system, the way to index to support the row number functions is what it calls a POC index. We want to make the key columns, the partitioning and the ordering. So the columns that are in my partitioning are key columns, and the columns that are in my order by are key columns. And then anything else, any additional columns that are not part of the P and the O, get added as included columns. So I would add store ID and actual cost. And the reason we do that is because, let's do it without the included column first, so you can see how that works. I'm going to add this index. Now, what do you think is going to happen with the query plan? It's going to, yes, so I'm going to have a bookmark lookup. And the reason for that, oh, well, you know what? No, because we did a clustered index scan. So because we pulled everything back from the clustered index, we've already got the information there. If it had used a non-clustered index to satisfy that first part, then it would do a bookmark lookup to get the extra column that's not part of the index. So in this case, if we put, and I still get my sort because it just doesn't know, the index is not, doesn't have everything that the query needs. It doesn't cover the query completely. So by adding that actual cost, now, it helps if you drop your index first, Christina. Let's do that. Here's the thing, when you create an index, it's like creating a whole new table. It's just a subset of the columns, but you've created a physical structure on the disk. So by putting all the columns that I need to answer this query into this index, I only have to go to the index to answer my question. So now when I rerun, now I've just done an index scan. There's no sort because I've pre-sorted the data by creating an index on it. And anytime you have sorts in your query plan, unless you absolutely can't avoid it, you want to get those out of there because they're expensive. So the whole point here, if it's a one-off thing, don't worry about it. But if it's something that's going to be run a whole bunch, then put the index in to support the window function. The two optimization things, remember to use row unless you absolutely must have range. And think about your indexing, your partitioning, and your ordering columns, and include the additional columns in the select output. Let me go back to my slides so that you have the link to the code. So all the scripts and the database that I used today are available at that link. And I think I have to upload them to the SQLBITS site too. I can't remember how that works. Yes?
I recently was involved in a performance optimization task on ordering about the same stuff that you just done there, but
Right.
ordered by a new ID, which was horrendous. The performance was just awful, and there's no way that I don't think that you could put any kind of index in place. So in the end,
No, because new ID gets generated each time.
And it was horrendous. I mean, we were looping through, it was going through maybe 10 million rows, and the process
Ouch.
took like 72 hours. So what the thing that we did was then to say, well, we'll kind of rewrite the code and use a cross-apply.
Yeah, I could see where that would have made a...
About 2 minutes.
So, okay, we really didn't have time to go into that, but cross-apply, you've looked at your window function, you know what your partitions are, you've determined what your subset is, you write the query for the subset. So in this case, I've got store ID and date. So I want to do my outer query, select distinct store ID and date, so that I've just got a list of the driver keys. Does that make sense? So I want to do this operation on every set of stores and dates. So select distinct store ID and date, and then cross-apply that into the full row number table, but in your where clause, where store ID equals the store ID from the top and transaction date equals the transaction date from the top. And now the SQL Server can make that go parallel because it knows that it's only doing that row number work on that distinct block of store ID and date. So that's a good way to when you're working with large number of rows, figure out what the smallest chunk is, and then make a distinct driver set to iterate. It doesn't really iterate through one by one, but the optimizer is going to turn that into a set-based operation. But what happens under the hood is that the threads, because they know that's all the data they're going to work on, it can force it on its separate thread, so it's gone parallel. It doesn't have to worry about keeping up with data from anything else because it knows it's only working on that discrete chunk. So it can use as many threads as possible to process it. Does that make sense? Cool. So yeah, the code is at that link, and feel free to send me an email or a tweet if you have questions. I'm happy to follow up. I know I went 90 miles an hour. I hope I hope you guys found it useful. Thanks for your time. And visit your sponsors and fill out your surveys.